Hello and welcome, ladies and gentlemen. We are still in topic 2 in lesson 1, also known as packet 1. We are in running circles around geometry. We are talking a lot about circles in this packet, in this lesson, in this topic as a whole. So this video is going to be us walking through the warm-up and the getting started portion of this packet. This one is going to be a pretty short video. The warm-up is pretty simple, and then the getting started is an activity that you should do with classmates. I will go ahead and talk about it, but we did it in class, so here we go. Okay, so warm-up. Write a description of each geometric object and provide an example. So a description of a geometric object and provide an example. For this one, I'm going to assume that you all know what a point is. Okay. Whether that's on a coordinate plane or whether that's just out in space, okay, or whether you're using your finger to point at something, it is a specific spot. And when we talk about geometry, right, we're using most of the time we're using graph paper or we're using shapes. Okay, a point is just like any spot, okay, any spot on a shape, okay, or in a shape. Okay, so there is a point on a square, if this is a square. Some points have special names, like the point, like if I have an angle here, the point of my angle is called a vertex, but it is still a point on my angle. It's just a special point. Okay, so a point is just a spot in space. There you go. Okay, a line, okay, a line, okay, goes through 2 points. So if my points are A and B, a line goes through 2 points and goes off into infinity and beyond. Go Buzz Lightyear. I hear they're making a Toy Story 4. I don't know if it's just an internet hoax. We'll find out shortly. Okay, but it goes through 2 points and then goes off into infinity and beyond in both directions that goes through both those points. Now, of course, they don't have to be flat. Say I had point C down here. Okay, I could have a line AC that goes through both those points. Okay, so that is another example of a line. They don't have to be flat, but again, both of these lines go through 2 points and then go off into infinity in both directions. Okay, line segment, okay, has 2 endpoints and is connected by a line. Okay, the thing that is different from a line and a line segment, a line goes off into eternity, infinity and beyond, like I was saying. A line segment has 2 definitive endpoints. Okay. Also, when we are denoting, so when we are talking about points, we'll normally just talk about them A, B, C, so on and so forth, right? This could be point A, this could be point B, this could be point C. When we talk about lines, we denote them. So if I wanted to talk about line AB, I would go AB, and then I would have this symbol over the top with the arrows, because lines go off forever, and those are denoted by arrows. So this would be a line symbol. Line segment, if I wanted to talk about line DE, I would put those 2 letters together, and then I just put a straight little line right here. No arrows, because it does have endpoints. If you'd like to help you remember, you can go ahead and throw some little endpoints on there, but most of the time you will see it without those. Okay, and a circle now, okay, describe the geometric object and provide an example. A circle, the definition of a circle, we can get really wordy with it, or if you want, we could just draw a circle. We know what that is. If you wanted to get really technical and you don't have to write this down, a circle is essentially a curve that is created by rotating something equidistant around 1 point. So if I have my point A here, and then let's say that this is 1 centimeter in real life, and I don't think that it actually is, but we can just pretend, okay? And then if I rotated 1 centimeter all the way around the center of this circle, or the center of this point, wow. If I rotate 1 centimeter away from this point, I would create a circle with radius 1 around this point. There we go. Okay, so circle, you can just go ahead and have an example there. You don't have to get into that wordy definition. So now we are on to getting started. Okay, we get a nice little story about a freehand circle drawing championship. This is a real life. This is something that people do now. It started when this guy, so this teacher, Alexander Overwick, or however you say this, okay, as a little joke, told his math class for over a decade that he was the world freehand circle drawing champion. And actually, his videos did go viral. And this kind of says that. It says, but the championship didn't really exist until a video of his circle drawing went viral, launching the first World Freehand Circle Drawing Championship in 2007. So this is real life. This is something that people do. I don't know how you train for freehand circle drawing, but I'm sure that it is intense. Okay, so here we go. Number 1 on our getting started says, try to draw a perfect circle like the one shown without tracing or using any tools. So here's the one that is shown that they're talking about. Okay, so if I went ahead, boom, I can just try without any tools. Okay, someone in our class was trying to use their finger, kind of like a protractor. They like put it down and then they rotated the paper around. That's definitely something you can do. Mine, obviously not perfect. I think it's pretty decent. Okay, so number 2 here. So number 1 literally just says try to draw a perfect circle. So I've done that. So now I'm on to number 2. Explain how you could decide whether one circle is closer to perfect than another. Use your criteria to judge your and your classmates' best circles. So one way that I was kind of talking about, circles are equidistant from the center of the circle. So if I went ahead and say this was my center, okay, and again, this is approximation. It's basically asking you to approximate who has the best circle. So if I put a point here in the center, and then I were to measure the distance from the center to here, to there, right? I could measure the distance from the center to all these places. And then the person who has the most perfect circle would have the most consistent distances as I went around all the way around my circle. Okay, it kind of looks like a wagon wheel now. So explain how you could decide whether one circle is closer to perfect than another. You could talk about the distance from the center of the circle, okay, and then using your criteria to judge you and your classmates, and then it says use your criteria to judge you and your classmates' best circles. Unfortunately, I don't have any classmates with me. I'm just here alone. Sad day. So I don't have anyone to compare with, so we're just going to move right along. You hopefully did compare with someone in class. If you didn't, maybe you were absent, maybe I gave you a free wave on that, but you would do that with a classmate. So now on to number 3. What is the measure of an angle that forms a perfect circle? What is the arc measure of that angle? Okay, so what is the measure of an angle that forms a perfect circle? Well, okay, if I go up here and let's say that this center is the vertex of my circle, or the vertex of my angle, okay, and let's say this is one side of my angle. Okay, if I made a 90-degree angle, that'd be straight up and down right here. Okay, so this would be 90 degrees, and that obviously 90 degrees is not what would create a perfect circle. If I went 90 more degrees, I would be at 180. That 2 does not create a perfect circle. If I go 90 more, I'm at 270. Okay, and so I'm going counterclockwise here. I started, this is my one side of my angle, and then I went, whoop, and I opened it up to 90. I opened it up to 180. Now I've opened it up to 270. So I'm looking at this, kind of like this part of my circle, right? So 270 degrees. Again, that's just because if I go 90, 90, 90, 90 times 3 is 270. So if I'm going from here to there, I'm not quite there yet. But if I add one more 90-degree angle, right? So now 90 times 4, I can go ahead and say that that would create a perfect circle, and 90 times 4 is, of course, 360. And then the measure, what is the arc measure of that angle? Also going to be 360 degrees. So what is the measure of the angle? The answer to that first part is 360 degrees. And then what is the arc measure of that angle? Also 360 degrees. Awesome, so that was our warm-up and our getting started. I told you all it would be a short video. If you have any questions, let me know. If you catch any mistakes, also let me know. It is good for part of it's good for an extra credit that is worth about half of a homework grade. So if you catch a couple of them, and I'm sure there are plenty, if you catch a couple of them, that's worth a homework grade. It could really help you out. Let me know if you catch anything. Hope you guys have a great night. I will talk to you soon. Adios.